Here we go. First of all, no, I haven't looked at your test yet, so I have no idea how they were. Second of all, this is very experimental. I'm kind of holding this iPad with one hand, and I'm going to try to do these notes with the other, and it's going to be hard because I'm actually looking at the screen of the iPad. I can't even see the paper underneath it, so I don't know how this will work out. Hopefully I can hold it still. So, here we go. Moving on to chapter 4. Here we go. So hopefully I don't sound like too much of a dork because I'm not going to re-record this. This is going to be all first try here. So, okay, this is really weird watching it on the screen and not being able to see my own hand. I don't know if I can do this. 4.1. The chain, nope, I can't do it. Move it over to the side a little bit. The chain rule, there we go, that's better, I can see. Hopefully that doesn't look too weird up there on the screen. Chain rule. So if you remember last week, I found it was section 3.4, number 25. It was one of your homework problems. That it was like I don't know, it was one of those ones where they were draining a tank, and so they gave you a function. It was this. It was the one that had the M there that threw some of y'all off. And you had to find the derivative of that. Just get rid of the M right now. You had to find the derivative of that, and the only way you know how to do it is to take that and FOIL it out, and then multiply by 6, and then take the derivative. Some of you tried to do 2, drop the 2 down, so you put 12 times 1 minus t over 12, subtracted the 1, so you left that as your derivative. But I told you that's not true. That's not what the derivative is. It doesn't work. So we had to FOIL it out, and that's too long. Now what this is, the chain rule, you're going to be able to do the derivative of that the fast way. What the chain rule is used for, it's for composite functions. This is a composite function. If you remember composite functions, we worked on those last year. That's like the good old fog, right? Where it was like, if f of x was, I don't know, 6x squared, and g of x was 1 minus, oops, I gotta move the camera here, t over 12, then f of g of x, take this one, oops, I guess that needs to be an x, take that one, plug it in there, so it would be 6 times 1 minus x over 12 squared. That's a composite function. It's basically you can split it into 2 if you want, and if you take one and plug it into the other, that's what you get. So to be able to do the derivative of composite functions, you have to know the chain rule. And if you want to know the actual definition, you can look in your book. It's on page 154. It's a rule 8. Oh yeah, see, okay. It's right there. Yep, whole bunch of, yeah, there's your fog, blah, 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 blah. You can look over that if you want. If you want me to explain it, I can when I get back. I'm just going to show you how to do it, how to use it, and the way I remember it. I think it's easier than they make it out to be in the book. So let's say we want to do the derivative of this, and now the iPad's in my way again, so there we go. Let's see, where was I? We're going to do the derivative of this using the chain. Basically what you do. Take the derivative of the outside. I'll call it the outside. So I'll go down. The derivative of the outside and inside.
Because if you look here, the outside would be like the 6, and then the square. It's like the outside. If I cover that up, that's actually the outside. The inside is everything inside the big C. So basically, you just kind of ignore this part in here, and do what you all thought you would do before. You take the derivative of the outside. Well, if I ignore that piece and do the derivative of what's there, I drop a 2 and I have 12 times the stuff in parentheses. So the first power. So I get 12 times the stuff in parentheses. And subtract the 1 to the first power. That's the derivative of the outside. Now all I have to do is multiply that by the derivative of the inside. So the inside the parentheses. So I ignore everything else and take the derivative of the inside. Well, you know the derivative of 1, that's goes away. So now the derivative of negative 2 over 12. That's the same as negative 1, 12, 2. So basically, just 12, right? So 1, 12 to the 0, 1. So the derivative of negative 1 plus 2 is 1. The derivative here of the inside is negative 1, 12. And now I multiply those together. Well, 12 times negative 1 plus 2 becomes 1. So now it's 12. So now that's becomes 2 probably going to be 1 plus negative 12. And now take the derivative. Pretty easy.
Do another one. You're gonna see a lot of. Someone's walking in. This is gonna be weird. I'm sitting here talking to myself. I'm filming some notes for. You want to be on it?
I apologize.
It's going on YouTube. Hold on, let me pause it. I don't know if I can pause it. Nope, it's just gonna keep running.
If you're busy, I can go away.
I don't think you can pause on this. No.
I'm sorry.